Before we can fix a problem, we have to know exactly what's broken. That's where monitoring comes in. Human activity is changing the land, air, water, and life on Earth. But these changes can be slow or hard to see right away. Scientists continuously collect data, samples of air, water readings, satellite images, to keep track of our impact. This monitoring data acts like a doctor's checkup for the planet, telling us if our actions are making things better or worse. The good news is that we don't have to guess how to fix things. We use fundamental scientific principles, the proven laws of nature, to design effective solutions. For instance, we know how matter and energy behave, so we can engineer systems that minimize the release of pollution or conserve resources. We're essentially applying the rules of science to reduce the negative consequences of human actions, making sure our solutions are grounded in solid facts. Let's look at the hydrosphere. A scientific principle tells us that water is the universal solvent, meaning it can carry many pollutants. To monitor our impact, we regularly take samples from rivers and oceans and test them for dangerous chemicals or excessive bacteria. If the tests show high levels of pollutants, that's our evidence that human activities, like factories dumping waste or storm runoff, are damaging the local water system. To minimize water pollution, we apply the scientific principle of cleaning and separation. Our best solution is the water treatment plant. This is an engineering marvel that uses chemical reactions, filters, and biological processes to remove contaminants from the water we use. You can help too, by simply avoiding pouring things like old paint or chemicals down the drain. You are preventing pollutants from overwhelming those systems and returning directly to the environment. Now for the atmosphere. A key scientific principle is that certain gases, like carbon dioxide, trap heat, and small particles can get stuck in our lungs. To monitor air quality, we use complex sensors across cities to measure the concentration of these harmful gases and particles. This data helps us pinpoint the sources of pollution. Is it car traffic, a power plant, or a widespread natural event? Knowing the cause is the first step toward the cure. To minimize air pollution, we are using the energy conversion principle. Instead of burning coal or oil, which releases dirty gases, we can capture energy that doesn't require combustion. That means shifting to renewable energy sources like wind and solar power. We're taking the sun's energy directly, or using the force of the wind to generate electricity without releasing harmful emissions. This engineering change directly targets the root cause of air pollution. The health of the biosphere is measured by its biodiversity, the variety of life. The principle here is that every species plays a role in a healthy ecosystem. We monitor this by tracking populations over time. If we see the numbers of certain animals dropping or local plants disappearing, that's a clear signal that human development has destroyed their habitat or introduced an invasive threat. That data screams, warning, the ecosystem is failing. A major solution for the biosphere is creating and protecting conservation areas. This applies the principle of spatial ecology. Animals need enough room to live, hunt, and mate. Engineers even get involved by designing solutions like wildlife corridors, special bridges or tunnels that allow animals to safely cross roads built by humans, preventing habitat fragmentation. It's about building our world in a way that allows nature to continue to exist. When it comes to the geosphere, one big problem is the sheer amount of waste we bury. The scientific principle of conservation of matter reminds us that when we throw something away, it doesn't vanish. The massive volume of trash in landfills is a direct measurement of our inefficient resource use. By monitoring how much and what type of trash goes into the ground, we can identify which materials we need to better manage. The simple, elegant solution for reducing landfill waste is the 3 R's: reduce, reuse, and recycle. This applies the principle of material conservation. By choosing products with less packaging, reduce, finding new uses for old items, reuse, or reprocessing materials like plastic and metal, recycle, we keep matter out of the landfill and reduce the need to dig up new resources from the geosphere. It's a closed-loop system, just like nature's. Let's drill down on the conservation of matter principle. It states that the atoms making up a product are still there even after we throw it away. A plastic bottle in a landfill might break down into thousands of tiny microplastics, but the matter hasn't disappeared. It's just transformed into a polluting form. Understanding this reality is the scientific basis for why we must manage and recycle waste, because that matter will persist for a very long time. Another crucial principle is that energy conversions are never 100% efficient. When you run a machine, some energy is always lost, usually as wasted heat. To reduce our environmental impact, engineers design systems for efficiency. For example, by putting high-quality insulation in walls and attics, we apply physics principles to trap heat in the winter and keep it out in the summer, significantly reducing the amount of energy needed to heat or cool the house. Modern technology is essential for effective monitoring. Think of a farmer using a satellite image to check the health of their crops, or a scientist using a drone to collect air samples over a volcano. These tools allow us to gather vast amounts of data over huge areas quickly. We can spot illegal deforestation, track the movement of ocean oil spills, and measure tiny changes in climate, all from space, giving us the evidence we need to act. In agriculture, we face the problem of fertilizer runoff. The scientific solution is precision agriculture. Instead of spreading fertilizer everywhere, farmers use soil sensors and GPS mapping to apply the exact amount of nutrients needed in the exact location. This application of science reduces wasted fertilizer, which means less runoff into the hydrosphere, directly minimizing water pollution and saving the farmer money. To deal with water scarcity, which is a growing problem in many regions, engineers apply the principles of phase change and filtration to create desalination plants. This technology takes salty ocean water and forces it through fine membranes or boils and recondenses it. The result is pure, fresh drinking water. This is an incredible technological solution that helps minimize the human impact of water overuse by tapping into a nearly infinite source, the ocean. Solutions must happen at both the small and large scale. A local solution might be a neighborhood starting a composting program to reduce landfill waste. A global solution is much bigger, like the Paris Agreement, where many countries agree to reduce their collective emissions of greenhouse gases. Both levels are necessary. We need worldwide treaties to manage atmospheric change and local action to protect our specific land and water. When solving an environmental problem, engineers often face competing solutions. For instance, a dam can provide clean hydroelectric energy, a positive for the atmosphere. But it also floods a huge area and destroys river habitats, a negative for the biosphere/geosphere. We have to use scientific data and modeling to carefully weigh the pros and cons of each option and choose the design that minimizes the overall negative impact on Earth systems. Applying scientific principles to real-world problems always has an ethical dimension. Our solutions can't just be scientifically sound, they also have to be fair to people. For example, when a state decides to close down a polluting factory, they must also figure out how to help the people who worked there find new jobs. Sustainability efforts must be balanced with the social and economic well-being of the human communities involved. It's easy to feel small when faced with global problems, but the cumulative effect of individual action is enormous. Every time you remember to turn off a light, you reduce energy demand. Every time you ride a bike instead of asking for a ride, you reduce air pollution. By applying the principles of conservation to your own life, monitoring your habits, and choosing wisely, you become a key part of the solution, multiplying the positive impact. In summary, we are using the tools of science to understand the problem and the tools of engineering to build the solution. Monitoring gives us the data, and scientific principles give us the rules for designing methods that reduce human impacts. Our path to a healthy future is about living in balance, using our intelligence to create technologies and practices that meet our needs while ensuring the beautiful, complex, and delicate Earth systems remain healthy for all life.